Hi all, in this video lecture mainly we are going to discuss on the topic. It's related to BOOTP protocol, that means Bootstrap protocol, and DHCP, dynamic host configuration protocol. So now let's have a look on BOOTP protocol. For Bootstrap protocol, it's a BOOTP protocol. Why we came for Bootstrap protocol? In order to overcome the deficiency in the case of RARP protocol we have discussed in the previous video lecture. So in order to overcome such deficiency, we have defined a new protocol is known as Bootstrap protocol. It's an application layer protocol with a client and server protocol, which provide the physical address to the logical address mapping. In that, the application puts the client and server on the same machine, or that means the same network, or it can be in the different network. For the client and server, either it can be on the same network or it can be on a different network. So there will be a Bootstrap message will be there that will be encapsulated in a UDP packet, and the UDP packet itself will encapsulate into a IP packet, that means Internet Protocol packet. So that's a basic scenario will be followed up in the case of Bootstrap protocol. Now we can discuss the Bootstrap client and server operations. So here the example which I have illustrated, the client and server are in the same machine. So in that scenario, the client simply uses all the zeros to represent the source address and all the ones to represent the destination address. The client uses all zeros will be as a source address and all the one will be used as a destination address. In that, the client and server are the application process. One of the advantages of comparing with the RARP protocol is that the client and server here are the application process. So the client can be in one machine and the server can be in another machine. So in that scenario, there will be a practical issue is that the Bootstrap request it's a broadcast message. So the broadcast message is an IP datagram which cannot be passed through a router. So in that scenario, there we need a intermediate. In the case of Bootstrap client and server operation, the client that know the IP address of the that doesn't able to identify the IP address of the server. So while they delivering the Bootstrap request, it's a broadcast message. So there need a intermediate agent in the case of Bootstrap client server operation. Now let's have a look on the BOOTP operation, where the client and server are on different network. So initially we have discussed in the BOOTP protocol, either the client and server can be on the same network or it can be on different network. So once it will be on the different network, there will be an issue we have discussed in the previous slide. So how we going to resolve that issue? We have discussed one intermediate is needed. So any of the hosts on the network, here it will be act as an intermediate. So the intermediate hereafter will be known as relay agent. So the Bootstrap request will be passed through the relay agent. For the relay agent, what they will do, they will encapsulate the message. Once the receiving from the Bootstrap client, it will encapsulate the message into a unicast datagram, and it will be passed to the Bootstrap server. So once the message is encapsulated into unicast datagram, it can be passed through any of the router. Once the message arriving on the Bootstrap server, it can able to identify the message if came via a relay agent. So it can able to identify the IP address of the relay agent, and based upon the message or request receiving from the client, it will pass the response to the relay agent. So from the relay agent, it will pass the message back to the response back to the Bootstrap client. That will be the operation they have carried out in the case of Bootstrap client and server when it's operate on a different machine. Dynamic host configuration protocol, that is DHCP protocol. In the DHCP protocol, it provides both the static and dynamic address allocation that can be done in the form of manual or an automatic manner. So in the case of dynamic host configuration protocol, if it go for a static allocation, it will be acting as a similar to the Bootstrap protocol. So it having a backward compatibility with the Bootstrap protocol. We already came across in the previous slide how a Bootstrap protocol will be work out. So in this case, in the DHCP server, there will be a static database that will contain the physical address binds to the corresponding IP address. So in the Bootstrap protocol, while a request come from the Bootstrap client, similarly here it will be DHCP client. Further request will become via a relay agent, and the relay agent will pass that one to the DHCP server. From the DHCP server, there will be a database. From the database, they will look into the corresponding IP address for the corresponding physical address and give a response back. That will be happen in the case of a DHCP static allocation. In the case of DHCP dynamic allocation, rather than a primary database, they are a DHCP server, they are maintaining a second database with a available IP address, a pool of available IP address they have maintained in the secondary database server. So once the DHCP client request comes, first it will check in the static database whether the corresponding IP address is mapped to the physical address or not. From which client the request come, the physical address will be checked over the database. If that available, it will return that one. That will be the permanent IP of the client. So but in the case of a dynamic allocation, while checking on the static table, if it is not available on the database, then the DHCP server will go to the available IP address. That means it will check on the second database and it will assign a IP address for a negotiable period of time. That means a fixed amount of time they will allocate the IP address to the DHCP client and add the IP address to the dynamic database. Such address is given as a temporary address. That is the mechanism they have adopted in the case of dynamic allocation. Again, I am repeating. Once the client requests come from the DHCP client, initially it will check on the first database, that means the static database. For the particular physical address, if any IP address is mapped, it will be returned. That will be the permanent IP address. If it's not available on the static table, it will be go for the second database. The second database it containing the available IP address. From that one IP address will be allocated for a limited amount of time and it will be added to the dynamic database. That address will not be a permanent one, it will be a temporary. That will be the mechanism they have adopted in the case of DHCP dynamic allocation.